I think for starters, it'll be immensely richer if we take the opportunity. Otherwise, we'll impoverish ourselves by restricting our field of activity to planet Earth.
Mm-hmm.
You know, we're butting up against the limits of industrial activity on Earth, whereas in space, there's a hell of a lot more room.
We are back with another episode of the Cold Star Project. I'm excited. It is late my time, and I don't know, fairly early his time. I have Adam Crowl here, the blogger at crowlspace.com. Lots of math on your site, Adam. I was just looking at that again, checking my way through it. So anybody who goes to crowlspace.com had better be prepared to do some thinking and some study. I want to keep it light today, though, not do too much math. But I do want people to know that Adam here has some serious space chops. I've wanted to have him on as a guest for a long time. And I've wanted to talk about space and take this podcast in a slightly different direction about futurist ideas and where I think we should go, because I personally am very invested in the space field, and I want to have large businesses in that field. So,
okay.
Thanks for being here. Let's begin with this, Adam. Why do you think space exploration is important? I mean, you get a lot of people who say, well, wait a minute, we should be spending these funds on helping the less fortunate or homeless or something like that. What about space exploration makes it more important than some potentially more pressing terrestrial priority?
Well, I always find it interesting that people think of space as somehow a big social project, whereas they don't think anything of building massive sporting stadiums or, you know, the entertainment industry, which some of the budgets for recent movies exceeds the budgets for various space probes to different parts of the solar system. So it's funny how that comparison always comes up. It's like, is space really a luxury? I mean, we have so many technological developments that have fed into industry and society thanks to space technology, which might never have existed, because most of the big social help programs generally have an idea of what they want to do from the start. They're not about innovation or development. They're really about applying what we already know. So really, yeah, it's kind of putting the cart before the horse. It's like the social change or social improvement that comes afterwards, but space comes before that. It's research, it's expanding horizons, it's developing new economies, new technologies, new ways of doing things. And that's why it's important.
Right. There is going to be an enormous economy that doesn't exist right now for things made in space and
yeah, exactly.
real estate in space. If I were able to put up a bunch of lab spaces in orbit, man, I would create a whole new economy right away. And you think about, say, a new heat shield tile being
possibly,
right? Mm-hmm. Take that and run with it. Where do you want to go with it?
Yeah, I mean, there's so many extreme conditions in space that are encountered like routinely. So developing the materials for that then feeds back into applications on Earth in ways that we never expected. Like the whole point is that it's a stretch goal. It pushes the boundaries, and if we don't push the boundaries, we never advance.
Right.
So it always seems to me like, you know, there are so many other things that really are luxuries that we could do without in a pinch. You know, people in wartime did without them. And no one goes, oh, why don't we stop smoking? Why don't we stop drinking? Why don't we stop buying marijuana? You know, it's like people want their luxuries. And they go, space is just another luxury. It's like, no, it's not. It's essential. So I'm just, yeah, and buying weed is something you do where it's legal, not where it's illegal. Okay.
All right. Well,
you can cut that if you want.
I'm gonna be in agreement with you there. So yeah, like I was jumping into, you think of a heat shield tile or something being invented, or a new kind of styrofoam filler or something, and that may be invented for the program, but it spills down and ends up in all kinds of products in the civilian economy. You know, suddenly it makes your house more heat efficient or something. So what do you think?
Well, it's like all I was going to say a lot of NASA research in the 70s was into um, what is it, teleoperation,
Hmm.
so remote control of machines. That basic research now feeds into telemedicine and
Hmm.
remote surgery and all those sort of enhancements. And none of that would have happened without that 1970s exploration of the concept.
Right. So 40 years
Or,
later,
or
we
it would
have
have been,
these cool robots going around hospitals, and the average person on the street might never encounter that, but it is improving our total quality of life.
yeah, yeah, exactly. I
So,
mean, yeah, electronics and semiconductors and all the rest wouldn't have got the leg up that they did without the 60s space program.
mhm.
They would have remained on the fringes, massive integration, and all those things that gave us Moore's law, and all the iDevices and clever gadgets we have now all came out of that basic research.
Right, right.
And that's what you're seeing the potential for. That synergy of doing new things in new ways will mean new industries and new
Mhm.
opportunities.
Right. And yeah, that is super exciting to me. Where do you think we ought to be concentrating as our first objective in private industry space development?
Okay. You mentioned space labs, and look, they've been talked about since the 70s. And it's not a bad idea, but it's not the booster, so to speak. It's
Hmm.
not the initial Kickstarter. Recently, Phil Metzger, who's a planetary material scientist, formerly with NASA, now with one of the universities in Florida, uh, has, with a few colleagues, put a good case for the commercial opportunity of mining the moon for water
Hmm.
to use for propellant in low Earth orbit to boost communication satellites to geosynchronous orbit. And by doing that, they think they can make money. And it's one of the first models of, yeah, this could really work, you know.
Right.
Um, but yeah, there will be new opportunities arise as industry expands.
So what we really have to do then is create some sort of construction industry in Earth orbit.
Well, yeah, not necessarily low Earth orbit. I mean,
Hmm.
it has pluses and minuses, but it is very deep down Earth's gravity well. If we want to source materials from further afield, the real place you want to park things in orbit is geosynchronous orbit, and then further out as more activity moves towards near the moon, or
Hmm.
places that are easy for asteroid payloads to come back from. So, like, there are a whole bunch of halo orbits around the moon, which are actually very easy to get to from near Earth asteroids. So if you're shipping materials back from there, that's where you want your first port of call. And then you can deliver it down to lower orbits or even back to Earth. But it doesn't have the fuel penalty of going so
Hmm.
close to Earth initially.
Right. Yeah. And I hope that's something, a basic concept that I would love to get across to our viewers and listeners is you got to think three-dimensionally when it comes to space, right? It's
Yeah,
not a 2D
exactly.
thing. There are gravity wells, and the expensive part of everything is getting it off of the Earth's surface, is kicking it up into orbit. And so if you have to keep doing that, it makes things horrendously expensive. Whereas if you can kick some stuff up into orbit or further out, and then start bringing things in that orbit that you were talking about to create more things, you're going to create that in an environment where you don't have to deal with that getting out of that gravity well. It's going to make things much cheaper.
Yeah, exactly. And the thing with gravity wells is they're not always a penalty. There are two stable points that trail and lead the moon in its orbit, the Lagrange L4 and L5 points. And they're kind of potential wells of their own. And just recently, they've managed to image interplanetary dust that is collected there. We don't know how much there is, but it had been theorized for 50 years
Hmm.
But the fact that we've now seen it means that, well, once we start going there, we'll get an idea of what we can do with it, how much of it there really is, and that could be an opportunity too. So you don't know until you go look.
Right.
It's
Somebody's
like,
got to take that initial risk, though, right?
well, one would hope that was NASA's role, and up until about 1970 it was, but since then they've seen just somewhat risk averse. But I think that's more due to the fact that I'm getting a little message, but anyway. But yeah, risk aversion seems to have become a dominant thing. But I think that's due to just budget uncertainties and that whole political environment that they operate out of. So that's why I think there's a much bigger role for commercial enterprise to take the risks. But generally, they don't take risks until they see a good chance of return.
Right, which is where you begin to get into that with this water on the moon concept, right? That we could go out there, get water, turn that into fuel, and then go get other stuff, minerals and whatnot from near-Earth asteroids and start making things.
Exactly.
Right, and the idea there's a great book called Asteroid Mining 101 that is very helpful for the regular Joe to understand what the heck we're talking about here, because this is not about going and getting platinum from some asteroid and bringing it back to Earth. That is not what anybody really wants to do. They want to get that platinum and turn it into something in orbit at that cheaper cost.
Well, part of it is like, okay, for an example, for on-orbit construction, a lot of communications companies would tell you that their bandwidth and the amount of channels they can handle would expand immensely if they could build big enough antenna arrays in orbit. I mean, SpaceX are going to put thousands of satellites up, so that's one solution. But for systems based in geosynchronous orbit, the arrays get really big. Now, packing that into a rocket and then boosting it up there is really challenging.
Right.
But if instead you can get the materials in space and make it on site, like a lot of companies are now proposing, then size is no longer an issue.
That makes a lot of sense. And antenna arrays are one of the big things that are areas of interest in space construction coming up. That's one of the key areas that I keep seeing. In just for our listeners and viewers to have a more complete picture here. In 2014, 2015, I knew I wanted to get into this field, and I got the guts to ask one of the vice presidents of business development of one of the two major asteroid mining firms for an interview. And I kind of tracked him down through one of his blogs and messaged him, and he said yes, and I got to talk to him for an hour. And that was when I first heard, oh no, we're not interested in getting grants from NASA. We want to develop our own private industry endeavors, right? That was a big eye-opener to me. I was like, oh really? Right, so for the last 3 years, I've been, for a while there, I fought the I'm not a scientist thing. That really held me back. It was a limiting belief. And finally I got past it, and now I'm like, okay, I can do whatever the heck I want. I can hire people to help me out with the science and the math. But the guts to do the idea and to form the idea and keep it together, that's what is really needed out there. So and so against that, you've got this risk averse thing with the public programs. So it really is necessary for these companies like SpaceX to go out there and there's Planetary Resources and DSI are the two main asteroid mining companies. And I can remember 20 years ago or more now, closer to 25, I was in high school, and I mentioned I wanted to run an asteroid mining company to a friend, and he kind of laughed at me. I was like 16 years old, and he said, that's fantasy. And I'll never forget that. He's forgotten. I'm still friends with him today. He's forgotten. I haven't forgotten. And the thing has come around to being a reality now. There are companies out there doing this, right? And I would love to step in and do that. So this has become a real thing. So, Adam, what do you think we should be concentrating on in terms of, like, say, reusable launch vehicles? Or one of my big ideas that I really want to get into is replaceable parts vehicles, right? So, you know, they're assembled maybe by themselves in orbit, and if something breaks, they just pop off a piece and put it on, and then go back out and kind of pull in some more asteroid stuff to process and send out. What else? What other things do you think are a priority?
Well, see, it's kind of too early to tell. Like, we know there are applications that are Earth focused. The question is, what's going to be out there focused? You know, as the in-space economy grows, there will be application opportunities that appear there as well. And it's hard to tell. Like, my favorite object in the solar system, aside from Earth, is Saturn's moon, Titan, because it has such a massive atmosphere and, you know, huge supply of hydrocarbons on the surface. Plus, it also has, like, energetic compounds. Like, it has acetylene, which, you know, we all use on Earth in welding gear and that sort of stuff. But on Titan, it forms a crystal, and there's, you know, possibly deposits of the stuff all over the surface. And so I kind of speculate, well, once there's stuff happening around the moon and so forth, might we want to source hydrocarbons from further afield? You know, a lot of space advocates talk about building settlements in space, and those will need nitrogen in their atmospheres. And possibly the easiest source of nitrogen out this side of Saturn's orbit is Titan, as strange as that sounds. So
that's kind of cool. For our listeners who don't maybe know too much about the use of these raw materials in our daily lives, I'd like to bring up the example of nickel in cell phones, which is a rare earth element. And there are mining operations going on in Africa that have been, you know, they've been going on for a long time, 20 plus years. I mean, I remember this being talked about when I was in college in the 90s. So they'll go and, I don't know, kind of sift these things out of rivers and that, and come up with the nickel, and there's warlord bands and people are not taken care of very well, right? So there's an awful lot of trouble being gone through to get this stuff on Earth. And I think it might be socially a lot easier to just go out there and get it from an unsuspecting asteroid that isn't going to fight back, or, you know, maybe it leads to some sort of solar system war after a while over resources. I'm not sure.
Well, I'm not sure about that. It makes for good TV. I mean, witness The Expanse. But a colleague of mine, Andreas Hein, recently studied the environmental impact of asteroid mining, and he found that it actually works out much better for Earth in so many different ways, if we can resource it in space, than on Earth. Because what we often don't realize is that to get at those minerals, an awful amount of other things have to be moved out of the way. And you have to refine through a lot of ore before you actually get the final end product. Whereas for a lot of things in space, it's quite possible that it will be there in relatively easily accessed veins of material within the asteroids themselves.
Right. Yeah, asteroids are not always solid rock. They're sometimes just composites of stuff, dirt and dust and clumps and things like that just happen to be held together for a while. So what do you think?
Well, the two asteroids that are being visited at the moment. So there are two asteroids that have orbiters around them at the moment that are active, Bennu and I'm not sure what the Japanese one's thing. And both those asteroids look similar, and they're essentially just big rubble piles. They have a very distinctive shape because their material is so loose that as it spins around, it just kind of forms this, you know, spinning top,
Yeah.
and that's due to it all being loose material.
Right.
So
So
yeah,
if we could send a vehicle over there.
asteroids will be surprising.
So
Yeah,
you're looking for more surprises. I know that one of the goals of one of those two big asteroid mining companies is to get a ton of small telescopes up there to start looking. They've identified a lot of hundreds of near-Earth asteroids, but they don't have a great idea of what's in them yet, and they've got to do this light analysis, right, to figure out, because you can figure out what's in the chemical composition by the light, the spectrum analysis. So that's the next goal for them, and they're starting to do this. What do you think that life is going to? Oh, okay, I'm going to stop because you want to comment. So go ahead.
I was going to say, you can, in theory, look inside asteroids using radio waves if you get close enough, because there's a natural source of 10-meter radio waves that's incredibly strong within our own solar system, and that's the planet Jupiter. So if you arrange a set of mini satellites around an asteroid that you want to look inside, as they rotate around and Jupiter comes in behind the asteroid, it's essentially like a giant radio X-ray, and they can look into the asteroid. So that's another possibility.
Okay. There's a lot of cool technology coming available. So then the delivery system becomes the important part there, I think. How do you get these telescopes out to the spot that you want? I think we can orbit them around the thing once they get there, but how do you do it cheaply and effectively? And then taking into mind the orbits of these things. I mean, there's a lot of math involved here. And I believe that there's great opportunity in simulation and remote control developments, because I doubt you're going to send up a guy in an asteroid mining vehicle that flies up to an asteroid. I would personally much rather send a drone or a fleet of drones that just go, and if they kind of process the stuff through the front end and poop it out back to some collective center where it gets processed. That's sort of the idea that I have in mind. And then if stuff breaks,
that's not a bad idea. It's I'm sure I've seen many different versions. It really depends on the specific resource that you're targeting, and the material properties of the asteroid. Some are essentially solid iron nickel alloy, and some are solid rock. Others are essentially asphalt layered over a core of highly porous, probably frozen water and other bits and pieces thrown in. And each one will have challenges and opportunities.
Right. So our stage that we're at right now, would you say that we've kind of got a lot of these mapped out, but we don't really know what is actually there, and we need to find out so we can prioritize, okay, what makes sense to visit first? Where are we going to get the biggest return on our investment? We're going to visit first. I think it's DSI has bought a company that runs a 3D simulation of all the asteroids in near Earth orbit, and you can go and watch this thing, and it's fun you can stick a date on it and see what it looked like then or will look like. It's just in black and white 3D animation, but it's pretty cool.
Okay.
So figure out what's going on. So say we get doing this and it's 200 years from now. What does our society look like, in your opinion?
I think for starters, it'll be immensely richer if we take the opportunity. Otherwise, we'll impoverish ourselves by restricting our field of activity to planet Earth. We're butting up against the limits of industrial activity on Earth, whereas in space, there's a hell of a lot more room. The challenges are different, but there's a lot more energy. I mean, solar energy is 24 hours a day in space, whereas Earth has night and atmosphere and dust and cloud and so many limitations on solar. So I think if we take the opportunity, just how far afield humans will go, I don't know. Like, every off-world environment is harsher than anything on Earth, but at the same time, yeah, there'll be people that want the space and freedom to try something else out there. One fun idea for a possible space habitat, which I hadn't seen discussed too much, was inside a lot of larger asteroids. They're quite possibly huge voids and cave systems. Well, not like terrestrial caves, but more like bits of asteroid leaving spaces between them. And that kind of internal volume is immense. So, you might want to burrow down so you can have a radiation protected region away from cosmic rays and solar storms.
Right. Yeah. People need to realize you can't just go up there and build something, you'll get irradiated. There needs to be very thick protection between you and the sun, which our atmosphere gives us. Thank you. Very thin little thing. And we exist under that. So yeah, like I can imagine building a very large ring habitat around the Earth at a higher orbit. But then there's the question of how do you protect from this radiation? So and debris and whatnot. I do have one question which I have personally sunk a lot of thought into, and I'm interested in your opinion of it. The Kessler syndrome. Okay, so the Kessler syndrome is I think it's been around since the 70s. You got this junk all up there, an ever-increasing bunk of junk, like up there in orbit, right? With satellites spinning out of control and going into a decaying orbit and filling up space in our sky. And as you're trying to launch things, the risk of hitting something increases. And also, the more space-focused we get, the more stuff is going to be put up there, right? And I can imagine the need for a traffic control system, and there's a couple of companies, one of which I recently saw featured to my chagrin on CNN. Somebody already thought of it and has gone into it. Maybe I'll buy it someday, I don't know, of how to traffic manage all this stuff, right? Keep track. Now, the Kessler syndrome is the worry that there will be so much junk that one impact will set off a chain reaction of explosions and create this massive dust cloud around Earth. And it's not ridiculous. Like, this sounds like science fiction, but it's not. And stop us from being able to launch anything for decades because there's so much junk out there. Now, I have thought, well, what if you had large batteries of energy to power lasers out there that could focus in and zap something, and you could AI this thing, right? Run it through artificial intelligence to figure out where the potential impacts are going to be, and this system would laser something before that first critical impact started. How realistic is that, do you think, or is it just impossible to get that amount of energy stored up or moved around to a single?
I don't think it's impossible. It's been seriously discussed. I think it runs into political problems, which should be obvious to anybody. Most suggestions for clearing out space junk generally involve systems that can attach to dead upper stages and deorbit them in a couple of months. And a whole fleet of CubeSats that can then latch onto things, and then they spin out electrodynamic tethers that then blow them out of orbit. Because my net connection says it's unstable, but anyway.
We had a bad moment there, but if you want to repeat what you said, I got the general gist of it, but go ahead again. A bunch of CubeSats that fly in, grab the thing, and drag it down to a lower orbit so it can decay there in the atmosphere.
And most of the junk problem is within that few hundred kilometers of Earth's surface. Geosynchronous orbit has the problem that there are a lot of defunct satellites there taking up valuable space. Most operators now will park their retired satellites in what's called the graveyard orbit, which is away from like a few hundred kilometers higher, which when you think about it, that's a potential business opportunity if their power systems and so forth are still operable. If you gang them together, you could get quite a significant power supply in space. But yeah, I think really the best thing is to avoid energy weapons that point towards the ground. It's not that they're going to be a risk to anything on the surface, but it does, like once you have that capacity, it becomes far too easy for it to become something you want to use against, whoever.
Right.
Um,
Yeah, you have this James Bond villain syndrome.
Yeah, and look, from GoldenEye and Diamonds Are Forever. I mean, but both of those were just ridiculous.
Right.
It's impossible to have a huge amount of power in space without it being obvious. Huge solar collectors or massive radiators for nuclear reactors will stand out. Any tracking agency would be able to spot them.
Right. Yeah, and I've looked at this a lot too about space warfare. It is impossible to. There's no stealth in space. There's always going to be a heat signature or something. There might be disguise in that you try and make something look like something else until, hada, actually it's missiles. They're heading to you. So
well, that was always the case against anti-ballistic missile systems, was that it was far too easy to hoax ground sensors. You could pop up radar reflective balloons, you can throw chaff. There's so many different ways of misleading your enemy. So while stealth is impossible, it is very easy to confuse.
Right.
But I'm sure that the Space Force will look at these issues. And I would hope that a sensible suggestion will be that it's their mission to, help solve the space junk issue.
Because that is a bigger issue and more serious than I think the average Joe on the street realizes.
Yeah, it's, what do they call it? It's an exponential collisional cascade, which, one satellite rams into another and it throws off three pieces that ram into three more, then so forth and so on. And very quickly they've all been hit by a chunk.
Right. Yeah, they're going at 18,000 miles an hour or something like that. It's just fast. And if you've ever seen a picture of they'll show you like a chunk of aluminum that's 10 feet by 10 feet hit by something tiny, and this huge half bowl is smashed into it. Right. It doesn't take a lot of mass to create a great impact crater when you've got a lot of velocity going, and that is how meteorites destroy massive forests and things like that. So, all right. Well, let's kind of wind it up there, Adam. I guess my final question will be, I'll have you on again. I think this has been great.
Yeah, no doubt.
What should people be looking for in the years to come, in the next few years, do you think, in space and privatization of space programs?
Well, okay. I know more than a few people have predicted this one, but you'll see the Space Launch System kind of put out to pasture. SpaceX or a competitor will be the heavy lift provider, at least initially, until other people join the field. And there will be a focus on reusing first stages. SpaceX have done it first, but other companies are ramping up to do the same. And look, first stages are generally the easiest, and why we didn't do it until now is due to pure historical accident, in that first stages are an awful lot like ICBMs, and thus all the effort went into that kind of technology crossover between missiles and launches. But I think that will then drop the price. So it might get interesting for smaller throwaway launch companies. Will they be able to keep up in that market? But the explosion in opportunity for CubeSats and smaller things are becoming more able to do more. And yeah, if done right, that'll do wonders. If done wrong, it'll be an awful lot of space junk. But most of them are
creating an opportunity to create more CubeSats to run and grab them and pull them down.
Yeah.
Could you quickly define a CubeSat for the general audience who may have heard the term but don't really know what it is?
Well, essentially, the name gives it away. It's a cubic satellite about 4 inches by 4 inches, 10 centimeters for those of you in metric. And each bit weighs about 2 pounds. And generally, there up to 10 of those subunits counts as a cube satellite. And they've got power systems, propulsion systems, communication systems, lots of pop-out antenna for if they want to talk to the ground. And as a result, they're immensely cheaper than regular satellites to make. And just about anyone can design them. There are high school students and undergraduate students who have designed them, and some of them have even had them launched. So it opens up the opportunity for anyone with a technological bent to get involved.
Right. I think that's very cool, because one of the big challenges that I've seen over the years is getting the public consciousness to get on board with space exploration, right? They'll have fits and spurts of it, but I would prefer that it was embedded in there. It was like living green, right? This is something we really need to be doing.
Yeah, and there's no reason why not. But yeah, of course, there's a certain amount of government bureaucracy and regulation and all the rest, and different administrators have tried over time to make it easier. And certainly things have improved over time legislatively, but it's still a challenge. As usual, the politicians are always the ones catching up to technology and not the other way around.
Right. All right. Well, thanks for being here, Adam. My guest today has been Adam Crowl, blogger at crowlspace.com. I highly recommend you go there and check it out. And I think we'll both agree that the layman should also go to Isaac Arthur's YouTube channel and pick up his amazing series of, I think he puts them out every week, of very intelligent space topics. And it's almost like a podcast, but it's even more entertaining than that.
Yeah, Isaac does it so well. Big fan.
All right.
Okay, thanks very much, Jason.
Thank you.